Press the bell icon on the YouTube app and never miss another update.
Okay. Now we'll discuss about the chemical properties of carbon compounds. So carbon compounds will exhibit different properties, and they are very useful to mankind and all, that we know already, the importance of carbon compounds and all. In that field we are going to discuss now. One thing is, okay, before going to this, let me say one very important concept, that is the compounds of only carbon and hydrogen are generally called as hydrocarbons. What are hydrocarbons? The compounds consisting of only carbon and hydrogen atoms are called as hydrocarbons. These hydrocarbons have played a crucial role in our day-to-day lives. Whatever the perfumes you use and detergents, soaps, all the other cosmetics and all, most of them are consisting of these hydrocarbons. Even our fuels, LPG we are using, and even coal or petroleum, all these things are consisting of hydrocarbons. Okay, so we already learned how to name those hydrocarbons in general based on number of carbon atoms, and hydrogens, how to write the formula and all we discussed. Along with that, I want to say one important concept here before going to the chemical properties of different compounds. As we discussed about homologous series, in the homologous series we have taken compounds with single bond, double and triple bonds between the carbon atoms. If the differences also we learned, if CH2 difference is there in one series, we call that particular series as a homologous series. And if that is, the homologous series is consisting of single bond between the carbons, we call that as alkanes, that series as alkanes. And the series which is consisting of double bond between carbon atoms, we call that series as alkenes. And if there is triple bond between two carbon atoms, we call that series as alkynes. This we already discussed, that is how to end up the compounds if there is single bond, double bond and triple bond, ane, ene and ine. These terminologies we discussed, but those series in particular they are called as alkenes, alkenes, alkynes. As we discussed, alkanes are always saturated. Alkenes are always unsaturated. Similarly, alkynes, they are also unsaturated. We can even find a general formula for this. If they have given you many compounds and if they ask, write the formula of that particular compound. Sometimes they give formula and say whether they are alkenes, alkenes or alkynes. To overcome those difficulty levels, if we know the general formula of alkenes, alkenes and alkynes, that will help us. How to know the general formula of this? As we all know, the differences between these homologous series is CH2, right? Here if I take N indicates number of carbon atoms, H hydrogen atoms, 2N plus 2. This is the general formula of alkenes. If I take a particular compound for that, that will become very easy for you to understand. See here. If I take ethane. Okay, and the next consecutive compound will become propane. Right? If I write the names here, it becomes ethane, and this is propane. General formula, how to generate it now. How many carbon atoms are here? 2. C2 H6 C3 H8. Here it will come like this. 8 hydrogen atoms. General formula if I write here, as we discussed already, the difference between them is CH2. This much of difference we have. How to write the general formula? If I take number of carbon atoms, that is N indicates number of carbon atoms, H 2N. 2N means here 2, N indicates number of carbon atoms, plus 2. Okay, let's verify here with this Cn. It becomes C2 H 2 into N means number of carbon atoms, that is 2, plus 2. What will the formula? C2 H6. 2 to the 4 plus 2. C2 H6. If you apply this here, same thing you can see. That is C3 H 2 into 3 plus 2. Then it becomes C3, 3 to the 6 plus 2, 8. H8. C2 H6, C3 H8. This is the formula of ethane, and this is formula of propane. These two are differing by the group of CH2 atoms, and that is called as homologous series. We have already discussed, and this is how we can generate the general formula for this Cn H2n plus 2. Okay. Similarly, if I take alkene, to this Cn H2n will be the general formula. Similarly for alkynes, these are also unsaturated as I said. CnH2n minus 2. 2 hydrogen atoms will be reduced because of triple bond. Here hydrogen atoms compared to alkenes, in alkenes 2 hydrogen atoms will be lesser because of the double bond. Here 2 more hydrogen atoms will be there because of the single bond. So these series are having the general formula as CnH2n plus 2, CnH2n minus 2 for alkenes and alkynes respectively. Okay. Now we discuss some chemical properties of carbon compounds. What are the chemical properties? The chemical properties we have seen in different chapters, like chemical types of chemical reactions and all. In that, in detail, we have discussed how to write the chemical equations, formula and all we have discussed here. So, among that is the properties whatever we have discussed in that, one let me take combustion. So combustion means we all know anything which is getting reacted with oxygen. We call such type of reactions as combustion. Usually, the carbon compounds combine with the oxygen to form carbon dioxide as the major product. This all we discussed already in the previous chapters. C plus O2 gives rise to CO2. But this will come for inorganic part. CH4. This is how to name this. One carbon is there. Meth. For hydrogen atoms. A. Methane. When methane combines with oxygen, it gives carbon dioxide, water molecule plus energy in the form of heat and light. Similarly, if I take ethyl alcohol, when it reacts with oxygen, that also gives carbon dioxide plus water molecule and energy in the form of heat and light. So this is how the combustion process takes place. And here we also call this as oxidation, right? Because oxygen is getting added, or generally electron addition we have discussed. What is oxidation? It's addition of electrons and all. So addition of electrons are taking place to form different compounds. We call that process as oxidation even. So in general, combustion is nothing but oxidation. But here, when we take the different compounds of carbon like saturated and unsaturated hydrocarbons, saturated hydrocarbons burns with very clean flame. They don't form any sooty flame and all. And more amount of energy will be generated there. Whereas if you take unsaturated hydrocarbons, saturated hydrocarbons, they are very good carbon compounds which will give more amount of energy when we use them as fuels. Unsaturated, they too will burn, but loss of energy will be more. Okay, so here they give sooty flame. Okay, the darkness will come in the flame and all, and the wastage of fuel will be happening here in this. So saturated compounds are the best fuels we can use. Are LPG, petrol. Okay, so these are very good saturated compounds and they give high amount of energy. Unsaturated hydrocarbons, they give sooty flames and all. When you come for coal and this petrol, they are consisting of nitrogen and sulfur compounds along with the hydrocarbons, and that only is leading to the pollution in our environment. And they give rise to nitrogen dioxide, trioxide, pentoxide, sulfur dioxide, trioxide and pentoxide, which are the pollutants of our environment. Next we will go for another concept. One point we discussed, that is combustion. Combustion is also one sort of oxidation. Here one point we will take, and the second property is oxidation. Before going to have the definition of this concept, let's take example or one carbon compound and we'll see what will happen to that. Okay. We all know that C2H5OH. It is called ethyl Eth2, ethyl alcohol, or we also call this as ethanol. Ethanol. When the ethanol is presence of alkaline. Alkaline means the compound which is having basic property, that is its pH will be more than 7. Alkaline potassium permanganate, KMnO4. Or you can also take the catalyst as acidic potassium dichromate. In presence of alkaline KMnO4 or acidic potassium dichromate, this ethanol will get oxidized. We must remember here, this potassium permanganate and alkaline potassium permanganate and acidic potassium dichromate, they are adding oxygen to this ethanol. What happens here? See, the new compound will be generated. CH3, here COOH. We know that COOH group, this indicates acidic nature, that is carboxylic acid. How to name this now here? 2 carbon atoms are there. Ether, carboxylic group is there, oic, ethanoic acid. When ethanol is reacted with the alkaline potassium permanganate or acidic potassium dichromate, it gives the compound called ethanoic acid. What happened here? See, these two are giving oxygen, whether this or this. I have written or here. If we take alkaline potassium permanganate, that releases more oxygen. See here only one oxygen is there. In this compound we find 2 oxygen, and this one extra oxygen is available from potassium permanganate or potassium dichromate. So this is called as oxidation. So carbon compounds undergo oxidation in the presence of different oxidizing reagents. As they are releasing oxygen, we call these compounds as oxidizing agents. Alkaline potassium permanganate and acidic potassium dichromate, they are oxidizing agents. They are releasing oxygen, and that is going to add with the ethanol to form ethanoic acid. And this is usually used in the preparation of our vinegar. Okay, acetic acid also, the name is also, the compound is also known as acetic acid. I hope you understood here. One combination we discussed, and the second point is oxidation. And the third property of carbon compound is addition reaction. Actually, what we are discussing here is the properties of carbon compounds. However, they are all going to react with the different elements and what the products they are going to form. In general, we are discussing. Here combustion we discussed in detail. Now oxidation we discussed. Addition of oxygen is taking place to the carbon compound to form the new carbon compound. Now we will take addition reaction. Before going for the definition and all, we will take one example. Okay, so here unsaturated carbon compound. What are these R's? This R represent rest of the molecules. Okay, it may be hydrogen. Okay, in general here if I take hydrocarbons, that will be hydrogen only. In other cases that may be a functional group. Here already double bond is there, one functional group, unsaturated compound. In the presence of the special catalysts like nickel, okay, the hydrogens will be added to the compound. When the hydrogen comes, R will be there. In the presence of nickel catalyst, this unsaturated hydrocarbon has changed to saturated hydrocarbon in the presence of nickel catalyst, and this reaction is called as addition reaction. What we are adding here, hydrogen atoms are going to be added for this unsaturated compound and making that as a saturated compound. So this is addition reaction. But here we need the catalyst. What is this catalyst? Catalysts are the elements which increases the rate of reaction. Okay, so which increases the rate of reaction. Such agents or the atoms are called as catalysts. So here we discussed about combustion, oxidation, addition, reaction. Now, one more concept. If we discuss, you might have seen some advertisements in TV and all. Vegetable oils are healthy oils, whereas the animal fats and all, they are dangerous to the health. Can you guess now which is good for our health? This or that? Saturated and unsaturated compounds. Usually unsaturated compounds are healthier for us, whereas saturated compounds are somewhat dangerous to our health because they will not react so easily for the chemicals which are there in our body. So better if we prefer vegetable oils than animal fats. Animal fats like ghee, butter, vanaspati and all will come there. Here vegetable oils we know, coconut oil and peanut oil. So those are unsaturated and they are healthier for our health. They just get added here to form a single bond. And another reaction is there, that is substitution reaction. Substitution reaction. Here the names themselves indicates what type of reaction is going on. Substitution reaction, it means something is going to be substituted. Okay, and here before taking the example, we just recall the saturated compounds are inert. They don't want to react with other elements or compounds so easily. Let me take one example. Along with this, we'll discuss special reaction. What's the name of this compound? This is methane. When methane reacts with chlorine, chlorine is a halogen. Okay, we know that usually the halogens are highly reactive, but we also know that saturated hydrocarbons are inert. They don't want to react with anyone. But here, if we apply some conditions, it means methane, when it is reacted with chlorine in the presence of sunlight, in presence of sunlight, this reaction will happen so fast. What will happen here? These hydrogen atoms will be substituted from chlorine atoms. Let me write here the equation. Let's take it. In the presence of sunlight, methane is going to react with chlorine to form CH3Cl plus hydrogen from here, one chlorine from here, that gives HCl. Methane, when reacts with chlorine in the presence of sunlight, the reaction will be very fast and it runs to form the compound CH3Cl, methyl chloride plus hydrochloric acid will be formed. If you keep this reaction continuously under sunlight, it follows like this. What's the name of this compound? Methyl chloride. Or it can also be called as chloromethane. Okay. If this is continuously kept under the same condition, these hydrogen atoms will all get substituted from this chlorine. See, CH3Cl plus Cl2 gives rise to CH2Cl2 plus HCl. Name of this compound? Dichloromethane. Dichloromethane. If the condition is continuously kept like that only, dichloromethane will get changed into CHCl3. Name of the compound? Trichloromethane plus HCl. Trichloromethane. We all know about chloroform. Have you heard of it? So that chloroform is nothing but trichloromethane. And if you continue the same situation, that trichloromethane again will get substituted by one more chlorine atom and form CCl4. CCl4. Tetrachloromethane or carbon tetrachloride. So this is how the substitution reaction takes place. For us, in our syllabus they have given only this much of reaction. That is, when methane combines with chlorine in the presence of sunlight, it gives methyl chloride. If you continue the reaction to be under sunlight, that gives all these dichloromethane, trichloromethane, tetrachloromethane. And every compound is having its own importance. As we discussed, trichloromethane, it acts as a chloroform. And here carbon tetrachloride, it's a very good solvent in organic chemistry. In most of the labs and all, it's a very good organic solvent. Okay, so this is how the substitution reaction takes place in the carbon compounds. Now we'll take a very important compound of carbon, that is alcohol. In general, ethanol. Ethanol formula we all know, C2H5OH. If you don't remember, you can write the structural formula. Structural formula means 2 carbon atoms. Functional group is OH, H, So this is the ethanol. H means 2 carbon atoms, right? All is the OH functional group, and the carbon valency has to be satisfied with the hydrogen. So ethanol. So ethanol, it's having a great importance in industrial fields. And what in general we call ethanol is generally called as alcohol. Okay, ethanol is generally called as alcohol. Melting and boiling point of ethanol is very low, 156 Kelvin. Melting point 351 Kelvin. It's boiling. Very less. We know that ionic compounds are having high melting and boiling point, whereas covalent compounds, they have very low melting and boiling points. So this is the general physical property of this alcohol. Alcohol, it's an active solvent for most of the organic compounds, and it's a good solvent. For that purpose, we use this in the preparation of tincture iodine, cough syrups, and many other tonics and all. Okay, and for that very special property, as it's a very good solvent. One more alcohol we find, that is pure alcohol, or we generally call that as absolute alcohol. Absolute alcohol. It is very poisonous. Okay. So in general, if alcohol, as we all know, it is soluble in water in different proportions. In almost all proportions, alcohol can be dissolved in water, and dilute intake of this alcohol leads to drunkenness. If in a more amount if we take, that will damage the internal organs of our body. So it is dangerous. Though it is dangerous in our society, to a large extent public are using these different alcoholic drinks. So absolute alcohol, as I said, it's a very pure alcohol without the mixture of water and all. But this is very dangerous. It is lethal. Lethal means it leads to death. The direct consumption of this absolute alcohol leads to the death of a particular person, whoever it takes. Okay, so these are the very general properties of this ethanol. What are the chemical properties of this ethanol? In general, this ethanol reacts with sodium. What happens when ethanol reacts with sodium? Let's see here. We know that sodium, it's a highly reactive element. what happens? C2H5 and so ethanol reacts with sodium to form sodium ethanoate. Sodium ethanoate. So this is the name of the compound. So what property we see here? Whenever the sodium reacts with ethyl alcohol, this hydrogen atom will be replaced by sodium and that product will be formed as sodium ethanoate. Then one more reaction is there here. Here what happens is, we know saturated and unsaturated hydrocarbons. If I take the reaction of alcohol with concentrated sulfuric acid. Before writing this equation or reaction, let me say you something about this very special acid, that is sulfuric acid. Sulfuric acid in general is called as king of acids because of its numerous uses in the industrial field and all. And sulfuric acid, it's a very good dehydrating agent, means it removes the water molecule from different compounds. To dehydrate anything, generally we use the sulfuric acid. Hope you understood. Here we will take one equation. Alcohol will take C2H5 OH in the presence of concentrated sulfuric acid. Just now we discussed water molecule will be removed. Here we have H5, OH, H2O if it gets removed. What will be the product? C bond C. Here H2, H2. This is saturated compound because we don't find any double bonds. So we have written the formula of this. See, C. We don't find any double bond between the carbon atoms. So this is saturated. Saturated hydrocarbons will be converted into unsaturated hydrocarbons in the presence of concentrated sulfuric acid. Right? So what we can say here? How to convert saturated hydrocarbons to unsaturated hydrocarbons. So using ethanol we can show this equation. Hope you understood this concept. So let's move further with different compounds of carbon. The last concept of this chapter we have here is soaps and detergents. Detergents. What are these soaps? These are also the carbon compounds. Long chains, the sodium or potassium, when they get combined with long chains of carboxylic acids, we call them as soaps. Alright? So here carboxylic acid group, we know COOH group. To this, number of carbon atoms will be attached. Here only few I have written. There will be many carbon atoms. Sodium and potassium salts of long chain of carboxylic acid is called as soap. One molecule of soap is consisting of this. Sodium or potassium salts of long chain of carboxylic acid are called as soaps. And as I have written here, they have two ends. This is ionic end and this is carbon compounds group, that is carboxylic group. And this carboxylic group is soluble in fats, whereas this ionic group is soluble in water. When the soap is formed, this is one soap molecule. When the soap is used to clean the cloths or any vessels and all, what will happen there? This molecule reacts with water. There, water, as we all know, formula is H2O, right? Okay. So, in this end will dissolve easily. It means this is called hydrophilic end. Hydrophilic means loving. Okay. Hydro, water loving end. This is called hydrophilic. And this end, that is carboxylic group as it is there, and this end, it will not react with water. It get repelled with the water. So we call that as hydrophobic. This end is called as hydrophilic. And this end is called as hydrophobic. Phobia means fear. Philic, loving end. Hydro, water. Water loving end. This is hydrophobic. It's having a fear towards water, so it will not react with water. Then this will react with the dirt. Usually the dirt of the cloths or vessels will be oily in nature. Okay. So in that, this compound or this end will get dissolved. Hydrophobic end will dissolve in the dirt material, especially with the oil contents of the cloth or any vessels. And this end is called as hydrophilic. Hydro means water, philic means loving. So water loving end we call. Now how the mechanism takes place here. Let me show you. Here is the dirt particle. We have long chains of carboxylic group. Okay. So same thing will happen. If dirt particle is there, these molecules of soap will arrange in this manner. Hydrophilic end, and this is called hydrophobic end. This looks like a missile. Okay, and we call this as missile. So this missile structure indicates how the soap will act as a cleaning agent. Here, whatever the oil content will be there, that will get dissolved in COOH group, whereas this end will directly dissolve in water, and this will be insoluble in water. It will form somewhat suspension, okay, that will get away when we wash the clothes. This is how the soaps will act. But sometimes what happens, when we use the soaps in circumstances, we have to rub it again and again, but we don't find any foam there. Why it is so? The concept will come to our mind because of the hardness of water, borewell water and all what we say. In such water, the cloths or the vessels will not get cleaned so easily. And why that is so? Why the water is so hard? That is because of the magnesium and calcium salts dissolution. Okay, the salts of calcium and magnesium, when they are more in number in the water, they give hardness to the water. In such a situation, we see the formation of scum, the insoluble part of that soap. Okay, so we call that as scum, and scum will form, but no foam is formed, and the cloths or the vessels will not get clean. So what to do in such circumstances? In such circumstances, we have one more carbon compound called detergents. What are these detergents? These are also the sodium salts of sulfonic acid. Sulfonic acid will be there, as we see here. Sodium and carboxylic group is there. Similarly, there we find sulfonic acid and sodium group. So that will dissolve the dirt so easily in it, and that will not form any insoluble substances called scum, and it will clean the cloths or the materials. So in general, we use detergents for that purpose. Generally, this is the petroleum product and acts as a very good cleaning agent. To this, we can end up this chapter. Thank you for watching.